MOSFET?
Because when I do one MOSFET, it doesn't give me a negative output for some reason.
I see. Okay.
Yeah, it wouldn't give me the negative because it's either this side is on or this side is off. And then if I were to input like a step function to make sure they switch back and forth pretty fast,
right,
it wouldn't give me a proper output either. And then let me just flip this one around. Let me see what it gives me.
So you're doing one that's type 1, right?
Yeah, I'm just doing one right now. So so it it wouldn't.
Okay.
It doesn't want to go down for some reason.
Okay.
Now,
let's look at your model one more time.
Give me a moment, because I'm only doing one at a time now. I think I'm.
So now you're trying to run both of them together. Is that right?
Yes.
Are you doing them serious, or are you doing only one of them?
I'm only doing one of them right now. Just one's model.
No, I understand. I mean, like, are you trying to activate both the battery and the ultracapacitor?
Yes. Yes.
Both of them. So both of them should be on together, right?
Yeah.
So then, I'll ask for control over your screen.
No worries.
Accept. Okay. Did you accept?
Yes.
Okay, here. So, for example, if I would like, this is the ultracapacitor, right? So if I would like the ultracapacitor to be on, I will turn this guy on, and then I'm gonna go here, and then this guy is certainly off. Then if I don't want to have the battery, then I'm gonna turn this guy and that guy.
Yeah.
If I want to have the battery, then instead of this guy, I'm gonna turn on this guy. You understand?
Yeah.
I don't really think that you need this, but we're gonna figure out why. And they are taking the same signal, right?
Yes. I think that one's wrong, man. I think I was messing with that one.
The only reason you might need MOSFETs back to back is if you have, because you see every MOSFET, it has an anti-parallel diode with it. So the only reason that I do that is if the current is gonna flow through the diode when I don't want it to flow through the diode.
Okay.
I'm not sure if there is any situation that this is gonna happen, because here, even when this is on, the voltage here is the battery voltage, and the voltage there is it negative? The ultracapacitor voltage. That might be something. Okay, let's keep them in this manner now. Let's assume that it's only taking one signal. Okay, so that's during the positive cycle. This guy is on, these two guys are on, and then this guy is on. Now, during the negative cycle, during the negative cycle, I'm going to be coming from here. Wait a second. Yeah, this is positive. So negative, I'm going to be coming from here, taking it with negative, and then these two guys are on, and then here, and then these guys. So it would be one, then going through the negative, then running through these two, and then coming through the battery, the negative, and then going out from here. Yeah, so is that the logic that you're following?
Yeah.
In your control?
Yeah, so I had the...
So let's see, what is your control? Is it here?
Yeah. I just messed with the test one.
I think you probably need to mess a little bit with this one. So these are all commented out. So where is where can I find A32 and A34? Is it here?
Yeah. And then it's on the top. It's in the top. Right there. I think I messed with it. Yeah, I was messing with it earlier. That's why.
Yeah. Okay. So I think that's the only thing that you want to see. So for example, it's going to be hard for me to debug it, but what you can do is that you want to make sure that these guys are getting the on signal during the whole positive cycle. This guy and that guy, and these guys are getting it during the whole negative cycle.
Yeah.
Right. So these are all low frequency switching.
Do you mind if
the high frequency switching would be probably here? So if I'm turning this on, I'm taking the battery. If I'm not taking it on, I'm not taking the battery, and then I can go out from here. So
let me just mess with this one.
So you at the beginning you can just take one of them. You can just take like, let's say I only want to take the ultra capacitor. So at the beginning you can only take the ultra capacitor. See, you can only turn this one on. Okay, let me.
Sorry.
So at the beginning, just try to take the ultra capacitor, and then these guys are on, and then go out from here. So keep this during the positive cycle. For example, you can keep this guy on, so he can take the same signal like these two guys.
Okay.
And this guy can take the same signal like these two guys. And then these are the only one that you keep turning them on and off during the positive cycle, right? And then during the negative cycle, it's gonna be the same thing. These guys are gonna be on, but this guy is gonna take the same signal like those, and 1, 2, 3 are gonna be off. So start slowly. Like first, show that I'm able during the positive sign, I'm able to get one of them on, off, and then in the negative, -0, and so on. Then try to put the ultra capacitor over the battery. So just start one thing at a time. You don't have to build from the same logic that we built in the other one. Design a logic that's going to make more sense in your head.
Okay.
Sounds good?
Yeah.
Yeah, try this one and get back to me slowly and fast on it. Like, just, are you able to just get the battery on and off? And then are you able now to add the ultra capacitor? Are you able to do 2 levels? So whenever you're debugging a problem, just like break it down to very small, tiny problems so that you can solve it.
Copy.
All right, cool.
Okay. Thank you, Professor.
You're welcome. All right.
Professor, I had a couple of questions as well. I was writing my report and I noticed that the
William, can you stop sharing? Yeah, thanks. Okay.
Oh, sorry. I was writing my report and I noticed that the ADC inputs for the microcontroller is only 20. I was just curious if we were originally designing it for ADC input for the voltage for both battery and UC and current for both battery and UC for 8 boards, wouldn't we need 24?
We would, but we wouldn't need current for every one of them because the current, they're all in series.
But if wasn't it originally supposed to be designed so that it would only run off the UC during like acceleration or high power density? So wouldn't the currents be different at different times?
Yes, but in no way we are connecting the battery and the ultra capacitor in parallel. They are always in series. So actually one current sensor is enough.
Okay, I saw that it can be connected in parallel, but I guess that's just not really a mode that we're going to be using.
Yeah, we're not actually. I don't think I don't think it can connect in parallel. No.
When I was reading, I think it was Sharon's paper or somebody's paper, they said it can be connected in parallel, and I looked at the configuration. It made sense to me.
Yeah, but in our configuration, no, we cannot. We didn't give that option to connect them in parallel in our configuration. Because if you connect them in parallel, then you're asking them to have the same voltage. That's not going to happen.
Yeah. Okay.
All right. I'm going to have a little bit of a longer talk with you, Josh, but let's see first Stephen and Xavier on the DSP side.
Yes. So I've been looking up videos to run simulations, like you said. because you mentioned we were just gonna run simulations off of Code Composer.
Yes.
Yeah, I've been looking how to run that because it's my first time using Code Composer, and
Okay.
and I've also in 138 we did a program to read the AD signals on the board, so I'm trying to replicate that code so we could use it on this project.
Okay. How is that going?
I just started this week, so I'm pretty much debugging at the moment.
Okay. Did you touch Tristan code or not yet?
I'm working aside from that. I'm not implementing it. I'm not incorporating the code right now.
Okay, so you're trying just to get more familiar with Code
Yes.
Composer and how. Okay, Xavier?
Pretty much the same, trying to figure out how to do.
Do you guys
More
meet? Do you guys talk at all?
No, it's been a little bit, but we should touch base because I've been looking for
should, yeah.
to emulate.
So that we wouldn't, so for different reasons, to accelerate the learning process,
Right.
you should. And the second thing, to start like assigning tasks to one another. So one thing, yeah, we need to learn how to do simulations in Code Composer. And the other thing, we need to learn the code. If I want to change the code, I'm not sure you guys can do that. Like very small things. Can you change the switching frequency? How to change the number of levels in the code? Like very small things like that. I wanna have confidence that you guys are able to do this.
Right. Right.
Okay. So there are different tasks. As so let's say that by next week, would it be a reasonable expectation to say that one of you would teach us the code in 5 to 10 minutes? Just tell us what's going on inside the code, what's every part is doing in the code, and then the other one would tell us how to set up Code Composer for simulations and how to test it on our own laptops. Is that a reasonable expectation for next week?
That sounds good.
Yeah.
Just one question.
Yes.
When you mention the code, there's 3 different files. There's a main and 2 other files besides it. Do you want us to explain all 3?
So I'm not really sure how he set it up. Usually when I set it up, I put everything in the main and the others are just for initialization.
Mm-hmm. So which one would you want us to explain?
The one that has the code, the main one.
Okay.
Yeah, not the initialization, because that's for someone who's just going to be working with this. I don't think we're going to be able to understand it. But you guys should.
Yes.
Okay.
Yeah. So I had a question about the code, and I wanted to kind of
also Zach, touch base with Zach if you have any more questions in the code itself. Zach is 100 times better than me. He can answer these questions better. But I'll see if I can answer your question. Go ahead.
Yeah, so I was looking at how we're going to prioritize changing the code and adding to it. Well, the first thing that popped up to me was adding, making it so it wasn't at one frequency, so we can actually have varying amounts of speed. And if maybe there's something else that we want to prioritize before that. I know that's a pretty big task. So since Steven and I are pretty new at like I'm pretty new at object-oriented programming.
So we wanna. So the reason I'm saying let's, for example, change the switching frequency, not because it's a priority for us, but just because it's something easy to do, and we can, if you do a mistake, we can tell, oh no, that's not the way to do it. Josh can do that. So we can revise after you what you did. But after that, there are different priorities. The first priority, as soon as you learn the code, is gonna be to start reading ADC signals. That's not set up in the code yet. Well, yeah, I don't think that's set up in the code yet to read ADC signals. So we're gonna need to do that very soon. And then the other thing would be to start applying feedback control using these ADC signals. So these are going to be the priorities. We know how to generate a PWM, but these are the things that are still missing in the code that we're going to be expecting you to work on it.
Cool.
Sound good?
Yeah,
Right.
I just want to double check the when you run it, it tells you which microcontroller that it's supposed to be. I just want to double check that it's the XTS 100, right? We're still using that one.
Say again, you want to make sure it's what?
The XDS 100 for the DSP chip that we're using.
Called XDS 100.
That's yeah. When you run it, it asks you which CPUs you want to be on for whichever microcontroller that you're using. That's the one that it popped up to me. So I just wanted to.
So why is this the one that popped up? Was that in the video or?
That was like Delfino, and the last digits was like XD or something. Like F.
Yeah, it's like
Some number XD.
yeah, it's got like two names. The shorthand name, which is XT, and then TMDSEMU.
Yeah, it's TMS. So I know that the one that we're using is TMS 320 F28 377D. So but I think that should be answered in the video. I honestly don't have an answer for you.
Okay,
But
that's
I
cool.
think that should be answered in the video. If there's any confusion, ask Zach.
Cool.
Cool.
Yeah.
All right. Dylan, Zach told me he's not going to be able to attend today because he had a work meeting at the same time. Are there any updates you would like to share with me?
Well, I'm just trying to write a test bench right now because that was what Zach last told me to do. So I'm in the middle of doing that, and I'm chatting with Zach about, understanding the module so I could actually write a test bench.
I see. All right. Sounds good. All right. Nisarj, let's.
Yes.
I saw what you sent me. It seems to be working now, right?
Yes.
It seems to be working even at loading conditions. Is that right?
Yeah.
Okay. So I would like to chat with you individually to tell you what's the next step going to be, but it's today is what how is your availability tomorrow? Because I think we're gonna need at least 15-20 minutes, just me and you.
Tomorrow after 12.
After 12. Okay.
Yes.
All right. Let me check my calendar real quick. Can we meet at 2:30 p.m.?
Yeah, sure.
Okay. I'll send you a Zoom invitation, and then we can meet tomorrow to discuss what's the next step that we're gonna need you to do.
Okay.
Sounds good?
Yeah.
Okay, Josh, David, and Jesus. Do you guys wanna give me any updates? And then I have updates for you as well, that something that we can work on, but go ahead.
I've mostly just been writing my paper. I've come across a few things that, because I guess with the intent of, how we would sort of do a redesign to solve some of the problems. So then I'm kind of like, other things are coming up, like with the gate driver circuit, or the sensing circuit, I mean. The amplification network is adding in summing of 1.65 volts. I assume that had to do with the reference for the ADC, but for the FPGA, it's like 2.4. It's external. And then, the second question was sort of, since you answered it in regards to, we don't really need separate current sensors for battery and UC, then should we just do one shunt and just do one current for each board?
I'm thinking one current sensor for the whole system is enough, but given that we have a central controller, because we're not controlling every board individually right now. So I'm thinking one current sensor for the whole board is enough.
So for each board though, or for one for the whole system?
I mean for the whole string.
Gotcha.
Just one current sensor, I think, should be sufficient for us.
Okay.
Okay. One thing that we want to do is that the current sensor, I know you guys sent me the design of the current sensor that we're planning to use again. Can you revisit that design and make sure this is the final one so that we can order it?
Yeah.
Okay. All right, David, anything you want to talk about?
Yeah, just looking into the common mode chokes that you want us to look at. Did you want us to put it only on the output, or like on?
So usually the common mode chokes are usually from the source to the load.
So on the batteries?
Let's assume that the batteries are our sources.
Okay.
Yeah. So that would be on the battery side. So where were your readings? Where did you read on this?
Yeah, I was just reading online, like just in general. I didn't find like a real reputable source on this stuff.
Okay.
Yeah.
So the best resources, you're gonna find them in industrial webinars. Texas Instruments, Viker, maybe
Okay.
Infineon, Skyworks, like the industrial webinars on this or industrial training videos and this. These are the best resources that you can use.
Okay.
Okay, so don't try to go deep into a lot of IEEE papers or things like that.
Yeah.
It's gonna be very confusing. But try to go to some of these industrial webinars.
Okay.
All right, Jesus, anything you want to add? Go ahead. Okay, so did you understand the circuit diagram? Did you understand what you did? Okay, great. So I have something, just give me guys 1 minute. Give me 1 minute, I'll be back. All right, so we are forming a new, it's mostly a sub-project. It's a project that's going to be composed of members of this team, mostly on the hardware side, which now we have 3 of you, Josh and David and Jesus, and members of the wireless charging team, mostly on the magnetic side, okay? So what they are doing, and I think you guys can be very helpful there, is that we are thinking about this new idea. I had been talking with a colleague of mine, an assistant professor at Princeton, and we wanted to work on this project together. The idea of it, you know, wireless charging, right? And I know at the beginning it's gonna sound weird that it has nothing to do with your project, but just bear with me. At the end, you're gonna find it's exactly your project with very small modifications. So you know wireless charging, that you have a transmitter, a receiver, there is a gap between them, and this way you can be charging your vehicle, right? Now, so that's one project. One of our project teams is working on this. Now, the new thing is that we were trying to do what's called dynamic wireless charging. So for example, here you have, that's a transmitter, and that's another transmitter, and then the vehicle is moving. And then while it's moving, it's getting charged from here, then moves a little bit more, and then gets charged from the other guy, right? And then as long as it's moving in the road, it keeps, whenever it passes over a transmitter coil, it's gonna get charged. So that's the idea of dynamic wireless charging. Now, the new thing that we would like to implement is, this is, when you do this, I'm getting power, and then 0 power or very low power, and then high power, low power. So you keep having some high power, low power sags like this, right? Your vehicle doesn't like that. So what are our options? People are doing some magnetic design to try to help with that, but you're always gonna have this, because now you're above it, getting a lot of power. When you leave it, you're gonna get less power, if any. And it's unrealistic to think that we're gonna have just coils that are meshed all over the road. So what we were thinking is that right now in this project, what we're doing is modular converters, right? So we don't have actually a DC bus where all the batteries are gonna get charged from this DC bus. We have more of individual control over them. Right, so let me share, let me open any file so that you can know what I'm talking about while discussing it. Yeah. All right. Okay, so for example here, that's similar to our system, that the battery cells are not connected together, right? So every battery is connected by itself to the other MMC and so on. So what we are thinking to do is, if we have wireless coils for every one of those, so basically that you already have the inverter for every battery, right? So if you have the wireless coil, the receiver coil that is part of the wireless power transfer mechanism for every one of those, then you're going to be able to charge them individually. So you're going to end up that instead of having one wireless pad for the whole vehicle, you're going to have a lot of wireless pads distributed all over the vehicle, so that every one of them is, and because you have, it's almost like a bus bar of wireless pads. And because you have many of them connected, then whenever you're going over the road, it's going to be a very smooth transition from one pad to another, because they are very close to one another. It's almost like a mesh of wireless pads, right? So this is kind of goes over the top a little bit, but the part that we are interested in exploring is building modular converters, very simple modular converters similar to this, or similar to what we have, and just H bridge, battery only, something like that, with the electromagnetic team that is working on the wireless charging. So any of you guys who's interested in working in this, whether Josh, David, Jesus, we're gonna learn how to build those in MATLAB Simulink. You already know that. And most importantly, in ANSYS, in electronic desktop in ANSYS. We now have full version for ANSYS, so you can access it from your home, from your own laptop. So we're gonna give you all this access, and then you're gonna be learning this new simulation tool, and then you're gonna be learning a little bit also about magnetic design from our students who are working there. So what I'm thinking is to form a small team, a couple of people from that team, maybe one or two from this team, and try to build a small simulation and start analyzing it. And then I'm gonna be working with you through this, okay? So first, any questions or any thoughts? Where is David? Did we lose David, or I cannot?
Oh no, I'm still here.
Oh, okay, here.
Yeah.
Okay. I was opening the wrong one. All right. Any questions or any thoughts? So it's not a requirement. It's a part that I'm adding to the project just to make sure, because you guys are working on hardware and you're hardly impacted by not going to the lab. So I'm trying to find new tools and new things, new skills that you can develop without going to the lab. So one of them is adding another simulation tool into your reservoir, and that's ANSYS. And then when you do that, you're going to add magnetic design into your reservoir. You're going to be adding what's called co-simulation, that we can do simulation between two different simulation packages at the same time. In this case, we can do Simulink and ANSYS. We can do Maxwell and Simulink in one simulation, and then we start seeing some results there. So that's something that I had been thinking about with the teams that are mostly affected. And that's why I'm thinking it could be a good fit for any of you who would like to join.
If I do like the extension that you're talking about, the 1 credit extension,
yeah,
then I would be interested. I think if I'm trying to graduate, which I already feel like maybe the extension might be a good idea, but I have a lot to do over the next month that I don't think I would be able to do it really until after then.
Yeah, that sounds good. You're up for it, okay. David, you're also...
I'm graduating.
You're graduating this semester, right?
Yeah.
Okay, sounds good. So I think what we can do is that David can continue working on what you're doing, the idea of adding choke components into the circuit, how to add it, how to design them, and all of that, so that when we get back to the lab, we have a clear idea what exactly to do and what we would be looking for. So we're going to have the common mode chokes and the differential mode chokes. So I think you can now just focus on this part. For Joshua, I think we can leave that as an open answer until you make a final decision whether you want to spend one more credit hour.
What do I have to do to do the extension? Because if it's just like through the summer, that would actually be kind of nice. Because right now I have like big projects in both of my other classes, and I'm actually got a lot to do.
Through the summer, I don't think you need an extension for that. I think we can, because through the summer, it's okay not to enroll in any classes and still be a student. That's my understanding. But
in terms of like getting the project done and getting like, the report and everything, is still, the deadline's still the end of this month.
Well, no, if you're going to do it through the summer, then it's going to be through the summer semester. So
Okay,
then we will
part of this 1 credit thing. I can push it to the end of this class to the end of the semester, or
so this credit would be for the fall, not for the summer. So if you wanna finish your project in the summer, you don't have to do anything. I'll just give you NC, not complete, and then in the summer I'm gonna give you the grade, and then you're gonna submit your report by the summer.
Okay.
Now, if you want to do it in the fall, that's when you want to take this 1 extra credit.
I see. Okay.
So the summer, you don't need to do anything. You just need to tell me so that I don't give you a grade, and you don't need to submit a report this semester and then submit it in the summer.
Okay.
Okay, yeah. But I think you're going to have to present this semester because there is no symposium in the summer.
Okay.
Okay. So that's something to think about. But given that Jesus is interested in this, what I'm thinking is that to have you added to the other team, and then you start building with them. So the expertise that they are going to need from you is building these multi-level converters in an electronic software, right? So you're going to be helping them with that part of the simulation, and then they are going to be helping you with teaching you magnetic design and how to interact between the multi-level converters and the wireless bands. And now, Josh, you can join that effort, or you can mentor him during this. It can be as much or as less involved as you would like to be. But
if he's working on it in the summer, I would definitely join him. And trying to learn. But probably for the next month, I'm just going to try to get as much done that I need to, with the project and the symposium and then my other projects.
Okay, perfect.
So I'll join just later.
That's perfect. So what we can do is that we can have a meeting so that's going to be 2 here and 2 from the other team for the 4 members, and start working on it a little bit. Because, and given that Jesus, you said you understand the schematics, so the new schematics is going to be very similar or even a little bit simpler. It's just going to be that the application is different. The software that we're going to be using is going to be a little bit different as well. But it's quite exciting, and we're writing different proposals for it. So it's definitely a new thing. So we will see how that's gonna go. I'm gonna email you guys, the two of you and the two of the other team, to set some time so that we can start getting together and kick this off. Sounds good? All right, cool, perfect.
Professor, I still have one more question. I think I kind of asked it earlier, but I kind of glossed over it. The one for the sensing circuit on this one, it has a 1.65 volt summing to
that's so that we wouldn't have negative voltage going to the DSP.
Right, but the FPGA is, I think, external ADC, so its voltage is like 2.4. So if we were to redesign it, since we don't need the current sensing ones, can I just use that space to just do a second like op amp network right there? So it could be, you can connect it to the FPGA or the ADC or the microcontroller. Because
you're saying that the FPGA is giving an external offset of 2.4?
Correct. I spoke with Zach about it. It's not the same.
What's the maximum voltage that the FPGA can accept?
I think it's like 5.
How much?
I think 5 volts.
So if it's 5 volt, then we don't have a problem because, well, yeah, the DSP can accept maximum of 3 volts. So if this one is adding 2.4 above the 3, that's around 5.4. So yeah, we might need to design something a little bit less. And there is no way to change this 2.4 offset on the FPGA board?
I don't know. I haven't even spoke with Zach. I was just writing my report and I was going through the schematics. And I'm like, so they add the 1.64 for the reference of the ADC.
Yeah, I mean, if we have
but then I just realized that there's 2 references, so we might need to.
Yeah.
I mean, if we don't need the current sensor, if you redesign the board, you'd have all that space because you could take out the bottom, hold 2 things, and then you could just duplicate it, but with a 2.4 volt instead of 1.65, and then you could just, depending on which one you use, you plug this one into the microcontroller ADC or that one into the FPGA.
I think that sounds like a good idea. One more thing, guys, before I forget. All of you have access to OrCAD if you need. You can have the full version. All what you need to do is, I'm sending you now the email of our system analyst, Audrey. Just email her, tell her that you're working with me, and then she's gonna set it up for you, give you a full OrCAD license. So this way, Joshua, if you wanna start working on redesigning or reshuffling some of the design of the one that we have between you and Jesus and David as well, you guys can start doing that. You guys can start sharing the files together and then start working on it, on the final design.
Yeah, I wrote the report up until basically the just redesigning, and that's kind of what I want to do next, was to get OrCAD and work with David and hopefully do because I know he's doing the current sensing stuff. And then also, I know I talked to you before about star grounding, so I'm going to research that and try to just come up with ideas that potentially could fix the problems that we dealt with in terms of testing, because that's kind of what mine was. I tested, I ran into a bunch of problems, so now it's like, how do I fix them?
Yes, so I think that's a good idea. Maybe, how about that, Josh and David, and then David also, you can add the choke design that you are having, the differential and the common mode chokes. You can add them also to the board. We can add all the learnings that we did, that we found, the bad filtering of the gate driver, the current sensor, the malfunctioning of them. We can just kind of reshuffle everything and finalize a good design for the future. So maybe that can be between you guys. Jesus, you can get slightly involved there, because I think, Jesus, we're gonna need you more if you're excited about this on the electronic desktop part on ANSYS. Also, Jesus and Joshua, I'm gonna send you instructions of how to download ANSYS. Also, you're gonna have full version of ANSYS that we were able to get to our students. Sounds good?
That's good.
Yeah.
All right, any questions from anyone?
Yeah, I had a question, but it's about the H-bridge operation and why we need the high frequency and the low frequency combination to operate from the
Yes.
DSP. Because I try to. Sorry, go ahead.
So let me share my screen again to explain on it. Okay, can you see me? Can you see the screen? Sorry.
Yeah.
So for example, let's look at this H bridge right here. I would like to charge the battery, right? Let's say I would like to charge the battery. So I would like to go through S1 and S4. Is that right?
Mm-hmm.
Now I would like to bypass the battery. I don't want to charge it. I'm gonna go through S1 and S2,
Mhm.
right? So what I said here is that S1 is gonna remain on all times, as long as you're working in the positive cycle. It's gonna remain on. And then S2 and S4, these are the two that are gonna do high frequency switching. Now let's go to the negative cycle. I would, or let's not call it the negative cycle. Let's say I would like to discharge the battery. That means you want to go through the negative side of the battery. So you're going to go through S3 and S2.
Mm-hmm.
Now I would like to bypass it. So you're going to go through S3 and S4. Here, what did we do? S3 remained on, S2 and S4 switched on and off. So that means that during the on cycle, S1 is always on. During the off cycle, during the positive, S1 is always on. During the negative, S3 is always on. And of course, they are vice versa with one another. And then S2 and S4, that depends on your control. So this is the part that's going to have high frequency switching. So that's why we decided to make one leg low frequency switching and one leg high frequency switching. This way we can reduce the losses in our system, because when you're switching all of them, you're going to have a lot of switching losses.
Okay, that makes sense.
All right, guys. Thanks so much for attending today, and yeah, gonna talk soon. Or don't forget to email Audrey if you need ORCAD. Josh and Jesus, if I don't get back to you with how to download ANSYS, remind me by tomorrow. But there is a README file. You have to go through it. It's gonna take maybe 15 minutes, 20 minutes for you to be able to download it fully. All right, guys. Talk to you soon. Bye-bye.
All right, bye. Thank you.